All in the module 1, that is key enablers for LTE features, that are we are going to discuss in the module 1. Today we will have a discussion about the wireless fundamentals, that is cellular concept. So in the cellular concept, first we wanted to know the basic concept of this. So first, what we will call it as cells. So that is nothing but the service area which divides into small geographical area, that we call it as cell. Okay, and this cell is served by a base stations. uh, to, so uh, to minimize the interference between the cells, the transmit power level of each base station will provide to required cell strength. Okay, so for that, what and all is needed? That is nothing but the first thing is frequency planning is required. So cellular principles if coming under handoff. What do you mean by handoff? Whenever the user move from one cell to another cell, the signal is going to be get transferred from the one base station to the another base station. We know that each cell is having individual base station. Suppose you assume that cell number 1, from the cell number 1, the user is in cell number 1, he is receiving a call and he started moving to the cell number 2. So what will happen? The cell base station from the cell 1 will transfer the call to the base station cell number 2. That is called handoff. Now uh, now the cells are actually spatially isolated, that we will call it as frequency reuse concept. Why we wanted to go for the frequency reuse concept? In the sense, if you use this concept, with the cellular system capacity will get increase. So here this is the thing what I have told. The cell is in the form of hexagonal size, and each cell is having a base station, that is transmitting as well as the receiving antenna. So I assume that when a person is traveling in the car, no, for this from the moving to this cell to this cell, the signal will be hand over to like this, right? See here they have clearly given, and these all are considered by the mobile switching center, can be managed by this. The next we will see what is frequency planning, why we wanted to use the frequency planning. Okay, so we wanted, so if we are using a frequency planning, some frequency factor has been determined. uh, for that we will say in the ratio of d, factor d. For that, the frequency reuse factor is defined as f, that is f less than or equal. What this means? That if suppose f is equal to 1 means that we will say all the cells will reuse all the frequencies. Okay, so like the same way, f is equal to 1 by 3, in the sense the frequency band is used by 1 out of every 3 cells. And for example, f is equal to 1 by 4, reuse factor is here. You see the color is defined, all the 4 cells, it is 1 2 3 4, this is using the same frequency. Here the reuse factor of 7, the cluster of 7 cells are using the same frequency. And in cellular system, as the cell size decreases, the transmit power of each base station is also decreases. And so we can say that the cellular system will support the user mobility, call transfer function from one cell to another, handoff process, all those things. So now in the diagrammatic, using this diagrammatic structure, we were very clear about what is the frequency reuse factor when it is f less than or equal to 1 or f less than or equal to 4. For example, we have taken reuse factor of 4 and reuse factor of 7. Now coming to the core cells. Core cells is nothing but it uses the same frequency. And here for example, we can take f is equal to 1 by 7. The group of cells which are using for the entire frequency channel set, we will call it as a clusters. So this is nothing but the cluster of a cell. See here, the border line, this is called cluster, and each cell, each hexagonal shape is called as a cell, and each group of that we are divided in the bolded way, that is called as cluster. That can be a 7 cluster cell or 3 cluster cell, like that. This depends upon our applications. Then followed by this, we think about the cellular system capacity. So here this system capacity will be increased. Uh, the cell should be smaller, and power can be reduced here. And also, as the cell size decreases, the transmit power of each base station also decreases correspondingly. Now coming to the handoff. Okay, this handoff will support the user mobility, as already I explained. We are moving from place to place or cell to cell. The geographical area is divided into a small cells, so that each cell is having a base stations. Okay, that is there. Now if we go for some advantages, small cells will give large capacity because of reduction in the power consumption, and it will allows the frequency reuse. And also drawback is also there, because cell size decreases means number of cells will also increases, so frequent handoff, managing and interference level also increases. This all becoming little bit problem. The next we will see about the if you come to the so next we will see in the place of cellular analysis of cellular system, that is nothing but there is a co-channel interference performance. So the co-channel interference will reduce the performance of wireless cellular system, and the interference in cellular network can be categorized into self interference, multiple access interference, co-channel interference, and adjacent channel interference. Among all this, other channel interference is also there. So what are the characteristics or features of other channel interference? In the sense, increasing the function of the radius of the cell. So other channel interference is to increase the function of the radius of the cell, and the radius of the cell is defined by capital R, and to the distance to the center of the neighboring cell. Okay, and also increasing the function of the transmit power. So these all are the put together, we will call it as other cell interference. Then if you come to the co-channel reuse ratio, that is nothing but spatial isolation between co-channel cells, and this can be measured by defining a parameter called co-channel reuse ratio. That is nothing but Z is equal to D by R, that we can give the formula of 3 by F, and 1 by F is nothing but size of a cluster. Okay, so here this F you have to take it into account that lower value of F reduces the co-channel interference, so that it will it will increase the quality of communication link as well as the capacity. Now if all these parameters are switched, then we have to think about the spectral efficiency. So here the overall spectral efficiency decreases with the size of the cluster. So F should be chosen in such a way that to keep the acceptable level of the signal. For that we need a signal to interference noise ratio should be maintained above the acceptable levels. So if the number of interfering cell is represented by n suffix I, the signal interference ratio for a mobile station can be given as, that is, S by I is equal to summation I is equal to 1 to Ni into Ii. So this S is nothing but received power, and I is nothing but interpower from the ith co-channel base station. So hope everyone understand the logic of the basic fundamentals of cellular systems, such as what is handoff, how frequency reuse planning is used, what do you mean by cluster, what is the channel interference and what are the things needed for the other channel interference. Thank you.